Today we are going to discuss the topic of Dataiku LLM Mesh and how it empowers organizations to build and manage enterprise-grade GenAI applications. As we all know, LLMs have transformed the way we approach the AI, making it possible to generate human-like text, assist with coding, create visuals, and much more. So in this session, I'll walk you through the tools and techniques that make it easier to harness the power of LLMs. So let's go ahead and explore the Dataiku LLM Mesh. Before we begin, let me give a quick overview on what are we covering today. So this session will start with what are LLMs. We'll give a quick introduction of LLM Mesh, and regarding the connection setup, we'll see the connection setup of OpenAI, Hugging Face, and NVIDIA. And then we'll also see some connection settings. So once connections are established, we'll explore key settings like security measures, PII detection, how to filter forbidden terms, toxicity prevention, and how to use caching and audit trails. After that, we'll see the RAG and Prompt Studio and how you can fine-tune prompts using Prompt Studio to optimize LLM interactions. We'll see some prompt engineering techniques like zero shot, few shot, and chain of thought with practical examples. And finally, we'll see a solution walkthrough of the demo of how can we use RAG with Answers API. So let's start the discussion on what are LLMs. So LLMs are essentially advanced AI models designed to mimic human language. Think of it as a really intelligent assistant who not only hears what you're saying, but understands the underlying meaning as well. These models are like pre-trained on massive data sets. It's like an encyclopedia of text and then fine-tuned for specific purpose. This is why these LLMs are so versatile. And speaking of versatile, LLMs are powering chatbots, virtual assistants, coding support, and even creative tasks like content generation. So they have becoming like indispensable in so many areas of our life. What we see here in this is an architecture of LLMs. So just to give a quick overview on this architecture. So on the left, we have the input text, say a sentence we want the model to understand. And on the right, we have the output text. It's like an output of the model. It can be like a translation or an answer to a question. So when we input text, the model, they don't understand raw words. So what it does, it converts it into like numbers called embeddings. Then it adds positional encoding to tell the model where each word appears in the sentence. This is very important to understand the context of the sentence. Multi-head attention helps the model focus on the most important words or part of the sentence, even if they are far apart. Feed forward, what we have here, is like a decision-making layer that processes this information further. Throughout the process, the model is constantly refining itself by normalizing data and adding the original inputs back. It's a bit like double-checking its work. Finally, it selects the best one, which we see as the generated response. We can see in the top there's like two layers, linear and softmax. The linear layer is like a translator that converts all these fancy calculations happening in the model into scores for each possible word in the vocabulary. Think of it as creating a list of potential words with their likelihood scores. And what we have on top of that is the softmax layer. It takes those scores and turns them into probabilities, like a percentage chance for each word. So this is like a high-level overview on what are LLMs. Now, once we have an understanding on what an LLM is, let's dive into the world of LLM Mesh. So LLM Mesh is a unified architecture designed specifically for enterprises building GenAI applications. The LLM Mesh, it acts like a central nervous system for your AI ecosystem. It seamlessly handles routing and orchestrating data across various sources and extracting tools, managing vector stores for efficient data retrieval, integrating with large models, whether through APIs or self-hosted solutions, and deploying outputs through tools like chatbots or enterprise applications. So when does it make to use an LLM mesh? We should ask that question. So for example, when multiple teams are working on LLM-powered applications, it helps keep everything organized and ensures consistency across the board. Secondly, when you're dealing with sensitive data like PII data, or you need toxic filtering or audit requirements, the LLM mesh is it's built to handle this kind of challenges securely. And finally, if you are rapidly prototyping GenAI application, the architecture can help you move quickly while staying efficient. As we understand of what LLM and when to use it, let's look into what are the features of LLM Mesh. So the LLM Mesh is a comprehensive framework designed for managing and deploying enterprise-grade GenAI applications. This, at its core, you can see it provides features like routing and orchestration to coordinate tasks across various components. You have cost reporting for monitoring expenses, PII detection and content moderation to ensure compliance and ethical standards, an audit trail for transparency, security and permissions for controlled access, caching to improve performance, and then you have retrieval augmentation to enhance models with external data, like if you're reading data through PDFs or images, those kind of stuff. The ecosystem, as we can see, it also includes accelerated computing hardwares like NVIDIA GPUs, hosted LLM API service such as OpenAI, AWS, and we can also see self-hosted LLMs like Hugging Face or Meta, and we have vector stores for storing and retrieving contextual information. So it supports a range of interfaces from a no-code and low-code tools for ease to use full-code environments for complete customization. And that's all these features combined makes it like a versatile solution for building AI application across teams and industries. Now, as we understand what are LLMs and we looked into the high-level overview of the features of LLM Mesh, now let's dive into the connection settings on how we can use this LLM in our Dataiku. So let's first talk about how Dataiku connects to various GenAI services. These connection falls basically into two main categories. They are API-based services and self-hosted models. For API-based services, Dataiku supports providers like OpenAI, Google, Anthropic. Using these services, it's pretty straightforward. It just requires API key, which you can get from your service provider. It is simple as plugging in the key and you're ready to use these powerful models in your flows in Dataiku. Apart from API calls, you can also use this self-hosted models. So if you're looking for more control, you can go into the self-hosted route. Dataiku supports models like those from Hugging Face. To use this, all you need is access token from your Hugging Face account, and you'll need a GPU and a code environment to set up and run these models. Apart from these two, you can also use more specialized models like Llama or Mistral. You must have a Hugging Face account where you need to have access to these models, but the access to these models needs to be approved. There is this added layer that ensures that you meet the licensing approval requirements before to use these models. So just to give a brief summary, Dataiku, it makes it easier to integrate with GenAI services, whether you want to quickly start with an API or build a custom solution with self-hosted models. It's all about the flexibility and control that you want in your project. So this is a sample UI here. You can see that we get in Dataiku. As part of the demo, I'll walk you through each connection section. But just to give you a brief overview, this is how the connection setup for an OpenAI would look like. First, as I mentioned, you'll need to enter your OpenAI API key to create a connection. Next is you have to select the model that you're using. You can select like text completion chat models. If you're working with images, you can use image generation. You can use embeddings, which is useful for tasks like semantic search or recommendations. And once you select the model, after adding the key, the next step is to define the network parameters. And you can define the network parameters like max parallelism. This is to control how many requests can be processed at once. You can define the timeout parameter, like to specify how long the system waits for a response. Then max retries, it's to set up how many times it should retry in case of a failure. So all these parameters, this ensures the smooth and efficient operations. With these steps, you'll have your like OpenAI connection up and running, ready to power various AI tasks seamlessly in Dataiku. Similar to the connection setup of OpenAI, we can also see here the connection setup that we can do for Hugging Face. First, if you're using private models, you'll need to provide your Hugging Face access token as discussed. This is not required for public models, but for private models, it's essential that you provide your Hugging Face access token. And once you provided your token, you can select the pre-existing models for text image generation, text vision embedding, summarization, depending on your use case. And you can also use custom models by specifying the Hugging Face model card details. And similarly, after you select the model and you provide the token, you can configure the runtime settings like containerized execution. So suppose if you're working in a containerized environment, so you can select the appropriate option here. Model cache, you can have the caching mechanism here. It enables DSS managed model caching to improve performance by storing frequently used models. You can have settings such as your code environment. So you can specify the internal code environment where the model will run, ensuring compatibility with your system. And the third setup that we can also do as part of our Dataiku connections is NVIDIA. Firstly, you need to install the NVIDIA NIM plugin in Dataiku, which enables integration with NVIDIA's LLM services. Once this plugin is installed, you define a preset key that corresponds to the model you'll use. And once you add it, then you select that NVIDIA LLM key that you're using. And after that, you can use this connection. Finally, you can configure, even for this connection, you can configure the runtime settings. You can set the maximum parallelism to control the number of simultaneous requests. You can adjust the network parameters. You can configure the retry behavior. And once you enter the values for all of this, you can seamlessly connect to NVIDIA's powerful models for tasks like chat completion or image generation, or which can be fully integrated with your Dataiku workflows. So once we have seen the connections on how we connect with the LLMs, the next important factor that we want to discuss is security. So these settings allows you to manage who can use this connection, view this connection, and it ensures proper access control. So freely usable badge. So this setting determines who can interact with the connection that you have just defined, whether it's creating new objects or browsing existing ones. If you provide it to as every analyst, as you can see here, it can be accessed all the analysts in your workspace. But if you want only a specific group that needs to have access to this connection, then you can also create a group and assign this group to only use this connection. The other option which we can see here as part of security settings is details readable by. So these settings controls who can view sensitive details about the connection, such as the credentials. If you select nobody, then no one can able to see it. And again, every analyst in your workspace would be able to see those connection details. And you can also restrict it again to a group, where if you have a dedicated group working on it, you can provide the access only to that group. As we can see, these settings might look basic, but these are very crucial for balancing usability and security, allowing you to customize access based on your organization's requirements while protecting critical information. Along with your settings of your connection settings, you can also define to filter any forbidden terms. Now, Dataiku provides a feature called forbidden terms filter, which allows you to block specific terms from appearing in your input as well as output, ensuring compliance with company policies or legal requirements. This feature is very useful in case of handling sensitive information like client names, project titles under NDAs, or other terms that could cause risk if exposed. So by setting up forbidden terms filters, you can ensure these terms are removed or blocked. This feature can be configured at connection level, and this can be done by the admins, providing centralized control. It ensures that all users who are interacting with the connection adhere to same restriction. You can also define the terms that you want to filter. It can either be through a regex matching, or you can have a source data set. It can be like a row of tables which contains all words that you want to filter, or the terms that you want to filter as part of your input and output, and that would act as your input for your connection. And in that case, any of those terms which are appearing in your connection, in your input or output, would be filtered out. Along with filtering forbidden terms in your connection, you can also do PII detection. This feature is also very important because protecting sensitive information is a very critical part of any AI system. And Dataiku leverages this to enable robust detection at the connection level. So PII detection can be applied to filter every query that passes through the connection, or it can prevent the query outright, like replacing the sensitive data with a placeholder. So as we can see in the example, we have an input which has a personal information like a name that we don't want to be exposed as part of our input or output. And as you can see in the result, we have replaced that sensitive information, and the result does not even recognize that noun. So it's like, could you please provide the name of the person you are referring to? So in that way, you can protect PII information. This also has multi-language support. This feature allows, as we can see, you can have supported language. It's just not restricted to English. You can have multi-language support in this. We can see another feature, which is confidence threshold. So this confidence threshold parameter is critical for reducing false positives. By setting a minimum confidence level, you ensure that only high-level PII is flagged, avoiding unnecessary interruptions. Along with PII, we can also do toxicity prevention. One of the challenges with LLMs is that they generate text by predicting the next most likely word in a sequence. Unfortunately, this means that they can unintentionally propagate harmful biases or toxic language they have learned during training. This is where the toxicity detection becomes essential. The toxicity detection ensures that the inputs and outputs of your models do not include inappropriate, harmful, or offensive content. This is crucial for maintaining ethical AI practices and preventing unintended consequences in your production environment. Whenever toxic data is detected, you can define remedies such as you can either block the input or output, or we can modify or replace the harmful content to ensure it aligns with acceptable standards. Dataiku provides the use of multiple toxicity detectors, which can be especially helpful during experimentation to compare and refine results. As you can see, there are two main engines that you can use in Dataiku for toxicity detection. One is the OpenAI Moderation API. This is a robust API-based solution for detecting harmful content. And the other one is local Hugging Face models. For on-premise or customized setups, it's provide flexibility and control. So if it's an on-prem, you can use Hugging Face models. You'll also specify the connection name to ensure moderation happens at the right integration point within the system. So it's very important to select the engine, and you should also specify the connection name that you want to have this implemented on. Caching and audit trail. So these are like the two critical features that enhance the efficiency and governance of LLM-based systems. Caching is designed to save LLM and embedding responses. This allows the system to reuse results for similar queries rather than making repeated calls to the LLM. So by reducing the number of API calls, caching significantly improves efficiency and it minimizes cost. Let's take an example if multiple users ask the same question or similar queries. So next we'll go over caching and audit trail. So these are like the two critical features that enhance the efficiency and governance of LLM-based systems. Caching, as we can see, is designed to save LLM and embedding responses. This allows the system to reuse results for similar queries rather than making repeated calls to the LLM. And by reducing number of API calls, caching significantly improves the efficiency and it minimizes the cost. For example, if multiple users are asking the same question or similar queries, the cache response is instantly delivered rather than making another API call, which will reduce the additional processing. Similarly, as we can see, audit trail, it keeps a detailed record of all LLM calls, including any failures. For instance, if a query fails due to the forbidden query check, the audit log will provide clarity on the reason for the failure. This ensures smooth troubleshooting, better governance, and it also tracks to you which LLM is being used and for what purpose, providing valuable insights into user activity. This improves transparency and accountability, ensuring that the system is being used ethically and efficiently. Together, both these features, caching and audit trail, like caching for efficiency and audit trail for governance, make your LLM workflows both cost effective and fully accountable, which is essential for any enterprise grade applications. Next, we'll cover the RAG and the Prompt Studio. So what we see here is a diagrammatical representation of a RAG. So as we can see, the process starts when a user submits a question. This could be anything such as what's the latest company policies or summarize this legal contract. Now what the system needs to do, it needs to provide a precise, contextual, relevant answer, often augmented with external information. So the process begins with user question. What we see here is a corpus of text. So this is the knowledge base or repository containing all the relevant documents such as articles, manuals, policies, or other textual data. Before the text can be used effectively, it undergoes several steps like chunking. So it's like breaking large documents into smaller, manageable pieces. Then the next step is indexing. It's like structuring the data for efficient retrieval. Then the third step is embedding. It's representing the text as numeral vectors to capture the semantic meaning. The process data which we have from the corpus of text is then stored into a vector store. So a vector store is a specialized database optimized for semantic search. It allows system to efficiently retrieve information that is contextually similar to the user's query. So when a user submits a question, the vector store helps identify the most relevant chunks of the text based on the semantic similarity. So once it's in the vector store, we have this component which is Smart Retriever. The Smart Retriever, it acts as a bridge between the user's questions and the vector store. It performs a semantic search in the vector store to find out the most relevant text chunks, which will be used to generate a precise answer. The retriever outputs relevant chunks of text that are directly tied to the user's query. Here we see there's a term prompt template. So prompt template, so the retrieved text chunks and the user's questions are combined into a structured prompt template. The template ensures that the language model has all the necessary context to generate an accurate response. Like for example, if the query is like, what is the refund policy? The prompt could look like user question, what is the refund policy? And context would be the relevant chunks from the vector store about refund terms. After the template, so if you go into the LLM query, The prompt is then sent to LLM for processing. This can be an API based LLM, as we have seen, like OpenAI, Azure, or it can be like self-hosted like Hugging Face. What the LLM does, it will analyze the context and the query to generate a response in natural language. Once it's generated the answers, the system produces an answer based on the LLM's output, ensuring it's clear and actionable. To enhance transparency and reliability, the system also provides sources for the information used in the response. This helps the user to verify the answers and build trust. The source can be from which page, or if it's a PDF document, the answer can include like from which document, which page number, which paragraph it retrieved the information for the answer. So if I need to give an end-to-end summary for this flow, so the flow begins when the user submits a question. The smart retriever identifies the relevant chunk from the vector store. The chunks and questions are formatted into a prompt template. The LLM processes the prompt and generates a response. Then the system outputs an answer, including reference to the source material. So that's how the RAG flow works. The next topic that we want to discuss is the embed recipe. So LLMs, they come with a limitation. They can only handle a certain amount of text in a query. To work around this, we use chunking and RAG workflows, which are essential for dealing with large data sets effectively. But let me walk you through how this works in Dataiku. First, we have the embed recipe, which lets you embed text by selecting the column that you want to process. You can also add optional metadata columns for additional context, which makes the embedding more meaningful. Then comes text chunking. This is where we break down large blocks of text into smaller pieces. You can fine-tune this by setting parameters like character count, chunk size, and chunk overlap to make sure no critical information is left out. Once the embeddings are created, they need to be stored for retrieval. And Dataiku lets you choose your preferred vector databases for this. You also get to select the LLM model you want to use, whether it's an API-based model like OpenAI or self-hosted like Hugging Face. And if you need more advanced chunking strategies, you're not only limited to the built-in tools. You can create your custom chunking logic using Python recipes. This flexibility makes it easier to tailor the process for your specific data set or use case. And together, these features will help you overcome all the LLM context limits while maintaining accuracy and efficiency in your workflows. The next, we are going to discuss about the prompt engineering techniques. So prompt engineering is a powerful technique for guiding LLMs to produce the results you want. It's all about crafting precise instructions or prompts to get the best possible output from the model. You can think of it like giving instruction to an assistant. The cleaner and more structured your instructions are, the better the results. So prompt engineering is basically the art of designing those instructions. To help with this, there's a collection of pre-designed prompts in LangChain Hub. If you wanna check out, it's a great resource for exploring like tested and effective prompts across various use cases. There are three techniques that we can use in prompt engineering. One is zero-shot prompting. Zero-shot prompting is the simplest approach. It's just ask the LLM your question directly without providing any example. For example, what is the capital of France? That can be the question, and the model directly outputs Paris. It's just a straightforward question and a straightforward answer. It's zero-shot prompting. But if you look into the second example, which is like few-shot prompt, the second technique, here you include a few examples along with your query to help the model understand what kind of output you're expecting. For example, you might say, translate these phrases into French, like a hello, and it will like hello to bonjour, goodbye to au revoir, and then you add your phrase for translation. So in that case, you provide an example for your translation, and then if you give one example, and then based on that example, the LLM would generate the output. The second can be a chain of thought. This involves asking LLM to reason thought through a series of steps before arriving to an answer. For example, instead of asking what is 15% of 20, directly you could say first divide by 200, by 100, then multiply by 15. I mean, this gives like a step-by-step process to the model, and based on the process that you have defined, the LLM would use that process and generate the output based on the process that you have defined. So prompt engineering, again, it's a skill that grows with practice, and by using techniques like zero shot, few shot, and chain of thought, you can make your integrations with LLMs far more effective and precise. In the next slide, we'll see a few examples of prompts as we discussed. In zero shot prompt, we directly ask the model for an answer without giving any example. We have seen this example, like we directly ask what is the capital of France, and it will give an answer. You can see here in this example, we have predict next quarter's revenue from historical data, and the straightforward instruction tells the model exactly what you want without extra context. For few shot prompting, we provide few examples to guide the model. Here's we have an example of healthcare. We say fever and cold corresponds to flu, headache and blurry vision focuses to migraine. So predict the diagnosis for sore throat and fatigue. So what will happen by giving these examples, you help the model understand the desired format and the reasoning process. In chain of thought, again, as we discussed, it guides the model through a series of logical steps before producing the answer. For example, in finance, you can start with total revenue, subtract total expense, subtract taxes. The result is the net income. This structured reasoning ensures the model follows a logical process, which is particularly useful for complex calculations or decision-making tasks. Next, we'll cover the Prompt Studio. So Prompt Studio is an incredible feature in Dataiku that allows you to experiment with different prompts and find one that best fits your solution. It's like a lab for fine-tuning your interactions with LLM. Prompt Studio in Dataiku has powerful functionalities. First one is create prompts. You can start from scratch with a blank prompt, or you can use existing template as a starting point. You can experiment with LLMs and RAG, test how differently different prompts interact with LLMs and RAG workflows. You can tune the LLM parameters, adjust parameters like temperature, top P, top K to control the creativity, randomness, or specificity of your model responses. You can test your prompt using manual test cases. You can either enter specific inputs to see how the LLM responds, or it can also be done through datasets, like run prompts against a dataset to validate how well they generalize across multiple examples. We have structured output validations. For example, for tasks requiring structured outputs like JSON, you can validate the output against required keys to ensure accuracy and completeness. One of the standard features is the ability to compare previously used prompts. This helps you analyze which prompt delivers the best performance for your specific use case. So in short, Prompt Studio, it simplifies the process of designing and optimizing prompts, making it easier to get accurate, relevant, and reliable results from your LLM workflows. Now, with all this understanding, we'll go through the demo of RAG with Answers AI chatbot. So what is Answers AI? Before diving into the demo, let's first discuss what is Answers AI. So Answers AI is a feature in Dataiku designed for creating virtual Gen AI based web apps. This features enables you to develop intuitive AI-powered interfaces that cater to diverse use cases. You can choose to use knowledge banks, which acts as a repository of information depending on your use case. And they help enhance the AI's ability to provide accurate and context-specific answers. Conversation history, as we mentioned, this feature tracks and retains user interactions, making the experience feel more natural and context-aware by referring back to previous exchanges. We have real-time document upload. Users can upload documents such as PDFs in real time, and the AI can process and extract relevant information on the fly. There's multi-language support, like Answers AI supports multiple languages, making it suitable for global applications where language diversity is a factor. It maintains user profiles, so the feature allows you for maintaining user profiles, enabling personalized interaction and a consistent user experience. So Answers AI makes it easy to create highly interactive, intelligent applications for extracting insights and answering questions in real time, providing immense value across industries like legal, finance, and customer service. So given this knowledge, let's dive into the demo that I have prepared. So as we can see in this, this is a small demo. So this, just to give an overview of this project. So this would cover the Prompt Studio and the Answers AI. So in this project, what we are doing is we are reading PDF documents. So these PDF documents are like contract documents, like health, marketing, and supply. So these are basically different areas of contract documents that we have, PDF documents. What we'll do is we'll extract information from this PDF, we'll create our knowledge bank, and then we create a web AI which will act as a chatbot where you can interact with that AI and ask your questions, and that AI would respond back with the information relevant to the documents that you have provided. So if you go through the flow, this is reading the files from the managed folders. This is the text extraction recipe that we have as part of Dataiku. It extracts the textual data from your PDF documents. After the PDF extraction, you can see for all the documents, what it has done is it has chunked each page size. So it has created chunks of each page, and you can see it has converted that PDF documents into a text format. So based on the number of pages, the number of chunks would be created. This chunking size by default, if you use, it's per page, but based on a use case, you can customize the chunking size of your documents, whether it can be chapter wise or bookmark wise based on your PDF. By default, the chunking size is 1, so it will chunk per page. Here what we see is another a recipe that we have from Dataiku, which is OCR. So this OCR is basically used for extracting image. So if you're dealing with documents that are image heavy, or for example you're dealing with any bank documents where you need to read checks or any handwritten images, so in that case we use OCR, which is pretty helpful in reading or getting data from an image. So yeah, so after the data is extracted, you create this knowledge bank, and using this knowledge bank, what we do is we create this Answers API. So if we go into the Prompt Studio, let me walk you to the Prompt Studio. So as we can see, this is a Prompt Studio that I have built. So what we have done is we have defined the contracts or the documents, and we have extracted data from those documents, and we created our knowledge bank, which has access to all the relevant information from the documents. We have properly chunked it, and if any data pre-processing is needed, that pre-processing is done, and we have created a knowledge bank, and that knowledge bank acts as a repository which has all the information related to your files that you have uploaded. So for example, now if I ask a question in my Prompt Studio, like the same question, what is the start date of the contract? In that case, if I run the prompt, what we can see is we get the answer here. The start date of the contract is June 30th, 1999. And as part of the response from the Prompt Studio, we also get the source, like from which section of the document it retrieved the data from. So it also gives the source. In that way, we can validate whether the information is correct or not. And similarly with the Prompt Studio, we have this web app. So this web app is like the Answers AI. So this acts like a chatbot. This chatbot uses the same knowledge bank. We can have the chatbot configurations here. And as you can see here, it uses the GPT 3.5 LLM, and it uses the knowledge bank of the chunk documents. So the chunk documents knowledge bank that we created as part of our project, so that would act as a knowledge bank for our Answers AI. So if you ask any questions to the Answers AI, it will only respond if it finds the relevant information as part of the knowledge bank. If you ask any question which is not part of the knowledge bank, then the Answers AI won't return any result. So it will return a result like a generic response, like it's not able to find any information. For example, if I ask the same question, like what is the contract start date, to my LLM, to my Answers AI, so it will try to query the knowledge bank and it will give the answer as the contract start date is June 30th, 1999. And if I try to ask the LLM some information which is not present as part of the document, for example, what is the mileage of, let's say, Honda Civic, if I give an example, and if I give some random information which is not present in my knowledge bank, then the Answers AI would give a generic information like, I'm sorry, I don't have information. So based on that, if you have like a use case where you want to create a chatbot, or where you want to, for a company or for any organization or an enterprise who want to create like a chatbot for their customer service or for legal or for finance reasons, then you can create your dedicated, like, it all depends on how you use the knowledge bank. So the knowledge bank is very important, and after that you can configure the answers or the web app here in Dataiku, and the knowledge bank would act as a source to this AI, and you can ask questions and it will interact with you and provide results for your questions. Along with that, I also wanted to show the connections that we discussed in our steps. So if you go into the connection settings here, let me go into the connection settings. So currently we are using the OpenAI API connection here. So as we have seen in the slides, for the OpenAI connection, you need to provide the OpenAPI key. You have to select which text completion model you are using. For in this case, we're using GPT-4. For text embedding models, we are using v3 small, and we went through the security settings. So you can define the security settings, whether this security setting is usable by every analyst, or you define a selected group. Details readable by, so all the OpenAPI, if you want all the analysts to read the connection details, so you can select here every analyst, nobody, if you don't want anyone to select. And again, if you want to select for a group, you can do selected groups. We saw the caching and audit trail. So for the usage control, we have caching. So if you do caching, it will cache all the LLM responses. So if there are multiple queries of similar multiple queries which are like pretty similar, then in that case it would read the data from the cache rather than querying it or making an API call every day. So yeah, this feature is pretty important if you want to achieve lower cost and faster access. And we also discussed forbidden terms. So forbidden terms, first thing is that you need to enable this. The source, as we discussed, it can be a data set, it can also be defined as part of a query, but the source is a data set. And in our project, we have defined the forbidden terms. So if I see, I've created a source data set, and in these data sets, I have created like a list of values that I want to be forbidden as part of my OpenAI connection. So what I've done is I've defined the source as a data set. The dataset project is the name of the project. The dataset is the name of this dataset, which is forbidden terms contract, and the column name in that dataset, which is currently I have only one column, which is terms. So terms, and contains ignore case. So if example, if you want to be case insensitive, then in that case you select this option. So this is the way in which you can define the forbidden terms as part of your query. Let me show you an example. So if you go into the prompt studio, and let's take security prompt for an example. So yeah, so as part of our connection, you can see we have few terms. For example, if we see in the forbidden terms, we have forbidden terms which is like hack, and we have hack. So if I enter statement like how can I hack the system, you can see the relevant response from the prompt. It says forbidden term hack found. Similarly, if you ask a query, what is hacking and phishing? If that acts as a prompt to your chatbot, then in that case, the prompt studio would respond with this. But if you answer a question, ask a question which does not contain any forbidden terms, in that case, the prompt studio would return the appropriate response. So yeah, so you can define the forbidden terms as part of your query. Similarly, you can also define the forbidden terms as part of your response as well. So as part of query, and similarly, you can also define how the LLM responds to your prompts. So in that case, you can also define forbidden terms there. Along with forbidden terms, you have toxicity detection, as we discussed. The first thing that we need to do is we need to enable this feature. We can use either an OpenAI moderation API or the Hugging Face model. And the other important thing is we have to define the connection that we want this toxicity detection to take place. So it's the connection that we have defined. For PII detection, if any of your queries it has PII data, then in that case you can define how your connection would react to those kind of PII information. So you can define whether it replaces the PII by placeholder. It can either reject the query, you can replace it by hash. You can either completely remove the PII or redact the PII. So these are the actions you can take depending on your use case. What your use case is, you can define what action you need to take if there's any PII data. Yeah, and similarly, we also have that forbidden items for response, and we also have toxicity detection for responses. So you can enable the toxicity even for the responses. You can define the engine that you want to use, either OpenAI or Hugging Face, and you can define the connection name. So this is how we do the connection settings, and that's how the Prompt Studio and Answers AI work in Dataiku. So in short, it all depends on the initial process of data extraction and creating a proper knowledge bank for your Prompt Studio and Answers AI. Once that's done and the proper information is provided to the LLM and Answers AI, then we can interact with the Answers AI, ask questions about the documents, and it will reply back with the appropriate response along with the sources. And if you want to research more on prompt engineering or LLM Mesh chunking techniques, so I have provided few links here. So these are pretty useful if you want to look into or research more on these topics. And that's it from my end. Thank you.